Well, there's no stopping our mad scientist when it comes to teaching us about the lessons of physics.
He joins us live with an experiment on atmospheric proportion. Good morning, Matt Selen. How are you?
I'm just fine. How are you this morning?
Very good.
We're great.
Okay, last week I asked a question, if you could take a 1 meter cube of air and somehow squish it into a little container or something so you could weigh it, how much would it weigh? And I got 2 great answers from people who actually figured out the exact answer. So that was very impressive indeed. Jenny Rush and Dale Trulock, both from Champaign, knew that the answer was about 2.7 pounds or 1.2 kilograms, which to me is a lot. I was kind of surprised when I worked that out. That means that all the air in this building weighs about 8,000 pounds. I mean,
wow.
That's a lot. So we can demonstrate this. In fact, I'm going to do that now. If you figure out how much of the atmosphere is above you and figure out how much that weighs, you see that every square inch down here on the Earth would have a weight above it of about 15 pounds. And that's a lot of pressure. And of course, that pushes from all directions, so we don't really notice it, but we have a way to do a demonstration here. So what I have is some boiling water in this flask. And what I'm going to do is I'm going to take this off. Right now, it's full of steam. When I put it in this cold water, which is down here, the steam is going to condense, and it's going to cause a vacuum to be inside this, or a partial vacuum to be inside this thing. So I'm going to put this balloon on top, and you're going to see what happens. Okay, so what happens was, there was a partial vacuum inside this container as the steam condensed into water. This 15 pounds per square inch from the outside just pushed the balloon through this tiny hole. Okay, so that's a cool way to illustrate atmospheric pressure. So we're going to do this on a big scale in the second segment right outside here. We're going to use atmospheric pressure to crush this big barrel. And so what I need to do that is heat the water, which is inside the barrel right now, by lighting this torch. And so there we go. So in a little while now, the water will be boiling inside. We're going to take the flame away. We're going to shut off the valve on the top, and then we're going to have this thing collapse, hopefully.
Huh. Okay. Well, we're watching anxiously to see. I have a very unscientific question.
Yes.
How do you get that balloon back out of that beaker?
How do I get the? Oh, well, you need long, skinny fingers, so I can't do it.
Oh.
I was wondering, how does it create the vacuum by changing the temp? Is it the temperature that causes the change in? How does that work?
Actually, let me shut this off. You get a vacuum because the air has been displaced by the steam that's in there, and when you put that container in cold water, the steam just condenses, and there's nothing left, and so you just you get a partial vacuum. It's not very good, but it's good enough that the difference between inside and outside is big enough that the outside pressure can push the little balloon inside, and that's the same reason that this barrel is going to crush in about 10 minutes.
Okay, well, we're looking forward to watching that. Always fun to see what you're up to, Matt.
Yeah, I'm looking forward to it, too. I hope it works.
We all do. Okay. Thank you, Matt and Selen. We'll be joining you again later in the hour for more physics fun.
You will indeed.
Wow. I like to watch
I want a torch on a stick for Christmas. That's what I want. You can heat things up from across the room.
No, you have to just
the
go.
guy thing.
Yeah.
Well, coming up.